In this video, we're going to look at similar triangles and the three theorems we use to prove whether or not two triangles are similar. Now, as in any similar polygon, triangles follow the same rules. Triangles are similar when all angles that are corresponding are congruent, and two, all corresponding sides are proportional. But with triangles, we don't have to measure every single facet of the triangle. We don't have to measure all the angles. We don't have to measure all the side lengths. There is a minimum amount of information you need. And the minimum amount of information creates three different situations. So, first situation, if you have two angles, call this angle, angle, and two triangles that correspond and they are congruent, that means they are similar. If you have the three side lengths, side, 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 in both triangles that are proportional, the corresponding sides are proportional, same ratio, then they are also similar. And lastly, if you have two side lengths and an included angle in that order in both triangles, with the angles being congruent and the side lengths being proportional, those triangles are also similar. So you don't need to measure every single bit of information here. So let's look at example number 2. So you have three options here. You can use angle, angle, side, or side, side, side. And just by looking at the picture and what's given to you, you should be able to determine which of the three you're going to use. So for example here, angle, angle is not going to be available to us because there's not two angles in each triangle marked. Okay. I know right now those two angles are vertical, so therefore they are congruent, but that's only one pair. So we can't use angle, angle. Side, side, side over here, you need three side lengths in each triangle. And in EFG, there's 63 and 42, but we don't know this side length. And KJ is also unknown, so we can't use side, side, side. So we're going to look at using side, angle, side. Do we have an angle in between two side lengths? In this case, we do. These two angles, these two vertical angles, are both in between a pair of sides. So we know for a fact that the vertical angles are congruent. That's the first tenet. The second tenet is, do the side length ratios match up? So if you check, 63, that's corresponding to 36, and 42 corresponds to 24. You have to see if these two ratios are actually the same. Notice how I kept them in the same order. I did big over small for both ratios. So if you do 63 divided by 36, you get 1.75. Now, if the second ratio is equal to 1.75, you'll have these two triangles be similar by side, angle, side. If the ratio is not equal to 1.75, the side lengths are not proportional, and these two triangles are not similar. So 42 divided by 24 is going to be 1.75. So these do, in fact, match up. So the corresponding sides are proportional, meaning they have the same ratio. So therefore, this is a yes, they are, and we used angle, angle to prove it. Now you'll notice this statement here, they say triangle EFG is similar to blank. You have to fill in the rest of the similarity statement based on the picture here. Now it's very important that you notice the order of the side lengths, E, F, and G, because the second triangle name has to follow the exact same order. So in this case, it's going to be triangle E corresponds with E in this triangle here, the smaller one. F over here corresponds to K, so that goes second. And then G corresponds with J, so that goes third. It's very, very important that you write the second triangle in the same order in which the first triangle appears as far as corresponding angles go. That applies for every single similarity statement. Look at number 5. Out of the 3 options or theorems, you can't use side, side, side because you have no side lengths marked. You actually can't use side, angle, side because of that very same reason. So we got to look at using angle, angle. So I need 2 pairs of angles in each triangle. Well, this picture has one triangle superimposed on top of another triangle. So this angle D actually represents 2 angles in 2 different triangles. But since they're superimposed, you can assume that angle D is congruent to itself. And for angle, angle, you only need one more pair. Now let's look at angles B and Q. 82 and 83 degrees respectively. They are not the same. They are not equal in measure. So therefore, you can't use angle, or you can use angle, angle, but it doesn't turn out to be true. So this is no. They are not similar. If I were to change one thing to make these 2 triangles similar, I could change the 82 degrees to an 83 degrees, therefore making them congruent, and therefore then the 2 triangles will be similar. But in this case, they're not, so therefore they're not similar triangles. They appear to be very close to being similar triangles, but they're not exactly similar triangles. Number 6, out of the 3 options here, side, 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 angle, angle, and side, angle, side, you can go ahead and cross out angle, angle, and side, angle, side, because they both involve angles. There are no angles marked in here anywhere. There are no angles marked in here anywhere, but for angle, angle, you would need 2 pairs. And for this triangle, you do actually have, let me write this side, angle, side here. You actually do have 1 pair, which is right here. Q congruent to Q. You could do side, angle, side. You could not do angle, angle, because there's not 2 pairs of angles. And you could also do side, side, side. So it's either or here. But we got to remember when you use side, angle, side, that the 2 sides surround the angle. So if you do side, side, or side, angle, side, you would be choosing these 2 that surround it, and you wouldn't bother with the 2 that aren't marked here. But I'm going to go ahead and use side, 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 because we haven't used that one yet. Even though you could use side, angle, side if you wanted to. So we have 3 sides to compare. It's called side, side, side for that reason. So you got to look at 3 ratios. And if they're all exactly the same, then the 2 triangles are similar. So the first ratio, 84 to 35. Those 2 side lengths are corresponding. Find out what that is equal to. Next one, 55 over 24. Notice the entire side length is marked here with the 55. And 24 is just from there to there. And lastly, we have on top here the combination of these 2 side lengths. So 42 and 56 actually add up to 98. So when they write it like this, the 56 from here to here, they just mean from F to R. So you need to add that to the total of 42 to get the entire side length of 98. And actually that goes in the numerator, not the denominator. So I'm going to erase that. So we're doing big over small. So 98 goes on top, corresponding to 42 on the bottom. Now if you go through and calculate all these ratios, they're all congruent, or they're all equal to each other. That means they're proportional. So 84 divided by 35, 2.4 is the ratio. Now if 55 over 24 is not the same, you can stop. And actually it isn't. 2.291